Okay, this is part 2 of the geometry quiz review. So I made this little chart related to triangles and their angles and their sides. So let's just real quick review. Scalene means all three sides different. Isosceles means there's at least two sides that are equal or congruent. Equilateral means all three sides and all three angles are congruent. Acute is three acute angles in the triangle. An obtuse triangle has one obtuse angle, and then a right triangle has one right angle, which would be 90 degrees. Obtuse would be greater than one obtuse would be one that's greater than 90, and three acute angles would be three that are less than 90 degrees. So let's look here. I'm going to use this chart, and we're going to look, is it possible to have a scalene and an acute angle at the same time? So it would be yes. We could have three different sides and three different angles that are less than 90 degrees. Can we have a scalene obtuse? Yes, you can have an obtuse angle, but three different lengths of sides. And then right scalene, yes, you could have that, because you could have, just think in our special triangles, you could have a 3, 4, 5 right triangle. So all three sides are different. It still has a right angle. Isosceles, acute, can we do that? Yes. We could have an isosceles where there's two sides that are the same and all the angles are acute. How about an isosceles obtuse? Yes, you could have two sides that are the same length, but there's an acute angle here, or I mean obtuse angle. And then how about isosceles right? Yes, you could do that too. You have two sides that are the same. These would each be 45-degree angles, and it would look like that. Now, how about an equilateral acute? Well, yes, that's true of an equilateral because these are all 60 degrees. So that's a yes. I better put these yeses here. Yes, 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 yes. Okay, now how about an obtuse equilateral? No, can't do that because all three have to be the same, and once you've got an obtuse, you're going to have two angles that are different, so that's a no. How about an equilateral right triangle? No, you can't do that because you have to have at least one right angle, so there's only 90 degrees left for the other two, so there's no way you could have three that are the same. Okay, let's think of some other possibilities. Could we have a right angle that's also an acute triangle? No, a right acute doesn't make sense because acute has to have three acute angles, and a right triangle has one 90-degree angle, so that's a no. How about a right obtuse? Can't do that either because if it has an obtuse angle, that's greater than 90 degrees, and you don't have enough degrees left over for your right angle. Can't happen. Never going to work. You're going to have a triangle that has more than 180 degrees. That won't work. Isosceles equilateral, or an equilateral isosceles. Yes, you could have that because an isosceles needs to have at least two sides congruent, and an equilateral has one. Now, will they always be that way? No. Equilaterals are isosceles, but not all isosceles are equilateral. Okay? How about equilateral scalene? Okay, well that doesn't make sense because equilateral is all three the same and scalene is all three different. So that's a big no on that one. Okay, I can't think of any other examples, so we'll move on from there. Okay, are these triangles, I'm going to give you three sides, three lengths of sides, and I want you to tell me, are they a triangle? Well, how about a side of 20, 28, and 12? And how do we know? We want to make sure that the sum of any two sides is going to be greater than the third side. So in order to do that, you just need to take the two smaller sides and add them up and make sure they're bigger than the largest side. So 20 plus 12 is 32, that's greater than 28. So yes, that could be a triangle. How about 10, 10, 26? So this would be like an isosceles with sides of 10 and 10. This would be no, because 10 plus 10 is 20. So even if I put those sides straight out, there's no way you can make a triangle, because their 26 is going to be a lot longer than that. So that's no. 10 plus 10 is equal to 20, and 20 is less than 26, has to be greater. How about 12, 28, 15? Well, let's add these together, and we get 27, and 27 is less than 28. So can that be a triangle? No, it's not going to work. Okay, let's try some other things. Okay, I made you two triangles here, triangle ZYX and triangle KLM, and they have these angles, angle 6. These are just numbered angles. This isn't their measurements, obviously. So 6, 7, and 8, and angle 10, 11, and 12. So I give you these parameters. Angle 6 is greater than angle 10. So angle 6 is greater than 10, and angle 7 is less than 11. So if angle 6 is greater than angle 10, we know that this side is smaller than this side. This one's going to be, oh, look, I just said that backwards. If 6 is greater than 10, this is the smaller one, and this is the greater one, greater side. And then let's see here. If angle 7 is less than angle 11, that means the one side across from the 7 is going to be smaller, and this is going to be larger. So now, can you compare YX to LM and give me an inequality symbol in there, and let's do KM compared to ZX. And so we're going to say, and you know what, I shouldn't put those markings on top because we're doing measurements. Let's take those off. That was a brain fart. Okay, so let's look. YX compared to LM. YX is greater than LM because this is the bigger one, this is the smaller one. And how about the measurement of KM compared to ZX? KM is also greater than CX because this is smaller, this is larger. So you see how I thought that out? 6 is greater than 10, so this side here is greater than this side, etc. Okay, let's try something else. Okay, so I want you to write me an inequality that would show me what the range of values of x could be to make this triangle work. So I'm going to show you the long way, and then I'll show you the shortcut. AB, the measurement of AB plus, well, let me back up. We got 3 line segments. We've got AB, we've got AC, and we've got BC. So for figuring out the possible values of x, remember the two sides added together must always be greater than the third side. So AB plus AC needs to be greater than BC. So that's these two. Then AC plus BC needs to be greater than AB. It's the second two. And then the third pair is going to be AB plus BC needs to be greater than AC. So you can just work these out. AB is 10 and AC is X, and that needs to be greater than 16. So subtract 10 and we see X needs to be greater than 6. AC is X plus BC 10 needs to be greater than, no, BC is 16, needs to be greater than 10. So we subtract 16 and X needs to be greater than negative 6. Well, that's not helpful information because all numbers, all of the lengths of the sides are always going to be, they're never going to be negative, so you don't have to worry about that one. And then AB, 10 plus 16 needs to be greater than AC, so we'll call that X. So 26 needs to be greater than X. So this is the high end, this is the low end, and you can just write it as an inequality. Put your 6 there, put your X in the middle, and use your less than signs. Okay, 6 needs to be less than X, which needs to be less than 26. Now, shortcut. We talked about this in class. You should notice that when you have your two sides, that to figure out the small end, we take the largest one here, take the larger one, and subtract the other one, and you get this end, and then add the larger one, and you get the high end. So that's kind of an easy way to do it. Subtract the smaller and add the larger, so to figure out the larger. Okay, so that's good. Now how about this? How about if I gave you a triangle like this, and so if I want you to tell me what could X be in order to satisfy this inequality, okay, so I don't know what I just said to you because I got interrupted, but let's look here. We want to figure out what could we put in for X that would make this triangle work. So I don't know if there's an easier way to do this, but what we want to make sure is that X is a value that will not allow any of these sides to be 0. So X plus 10 needs to be greater than 0, so X needs to be greater than negative 10. X plus 14 needs to be greater than 0, and so X needs to be greater than negative 14. And then 2X plus 2 needs to be greater than 0, so I'm going to subtract 2 and then divide by 2, so X needs to be greater than 1. So in order for all three of these, I'm going to take the one that's the highest, because these obviously, if X has to be greater than 1, these values that are below 1 aren't going to work for this side of the triangle. So I'm going to put 1. X has to be greater than 1 to make this work. So otherwise, if I put 1 in here, 2 times 1, you know what? Just shoot me in the head. It has to be greater than negative 1. Sorry about that. X is greater than negative 1, because if I put a negative 1 in here, I get negative 2 plus 2, and we get a side of 0. So it's going to have to be higher than negative 1 to prevent this side from being 0. So there you go. If there's an easier way to do that problem, I'm not sure what it is. So I just tried each side and found the one that would work with all three. Okay, so that's part 2, and I'll see you tomorrow, and good luck on the quiz. Okay, study your notes and your homeworks. Okay, I'm going to add one more thing to this problem. Instead of just solving for X like that, what if I gave you an inequality and said to you, hang on a second. What if I said to you, A, B AB plus AC needs to be greater than BC to make this work? Well, let's try that. X plus 10 plus 2x plus 2 needs to be greater than x plus 14. So let's say I have 3x plus 12 is greater than x plus 14. So I'm going to subtract x. So I have 2x plus 12 needs to be greater than 14. Now I'm going to subtract 12. And I get 2x is greater than 2. Divide by 2, and x needs to be greater than 1 to satisfy this inequality that I gave you. And I could make up any one of the three and just say, what would it be to make it work? You know, I could say, let's do BC plus AB needs to be greater than AC, like that. And you could try any combination and figure out what would X need to be to make that particular inequality work. So anyway, I'm going to leave it at that, and we'll see you tomorrow. Bye.